Hi class, welcome to lesson 11 on physical and chemical changes. This is your final lesson in unit number 1. That means a test will come soon. To find your unit review sheet, just go to Google Classroom. In this lesson, we are going to differentiate between physical and chemical changes and list the 5 evidences of a chemical change. Let's get started. So here's a little bit of a flow chart to help you distinguish the difference between a physical property and a chemical property. Physical properties are properties that can be observed without creating new substances, which essentially means without creating new bonds or breaking existing bonds. Some physical properties that you can observe are things like states of matter or density. You can look for keywords like melts, boils, solidifies, freezes, dissolves, is crushed, bends, and conducts. Chemical properties, on the other hand, are properties that can only be observed through a chemical reaction. In chemical reactions, bonds are either broken or formed, always creating new substances with new properties. The only way to verify that a chemical reaction has occurred is to test the new substance to see if it indeed has distinguishable properties from the starting substances. But since testing properties such as melting point, boiling point, density, electrical conductivity, and solubility of water can take a long time, we have 5 evidences that we'll look at that are good indicators that a chemical change has likely occurred. Those include a change in color, a change in odor, heat and light being given off, a precipitate being formed, or effervescence, which is the production of gaseous bubbles. Some keywords that indicate that a chemical change has occurred includes reacts, burns, and decomposes. Physical properties are characteristics that don't change the identity of the substance when tested. No new substance is produced, no new bonds, no new substance. Examples of physical properties include density, crushing, solubility, conductivity, melting and boiling point, and phase changes. So the substance, meaning the name and the formula and therefore the properties, doesn't change. Only the form or the physical arrangement of the particles changes. So here you can see the example of when we start with solid water and we melt it, we can produce a liquid, but it's still water. And when we freeze that liquid, we can turn it back into a solid, but it's still water. Another really good example of a physical change is the dissolving of sugar in water. Physical changes produce mixtures because the components are simply physically combined, not bonded. So when we add sugar to water, as it dissolves, it spreads out uniformly to create a solution. But the sugar maintains its properties. It's still sweet. And the water maintains its properties. It's still wet. When we look at the formula, notice that we begin with table sugar and water, and then we end with table sugar and water. No new formulas, no new bonds, no new properties. So here again, you can see that there's just a physical rearrangement of the particles, but there are no new bonds and no new properties. Another really good example of a physical change is melting of chocolate. So here I've simplified the formula to just be that of sugar, but if you melt a substance, the formula you begin with and the formula you end with are the same. The only difference is the state of matter. So I began with a solid where the particles or very tightly compacted and tightly arranged, to a liquid where the particles are able to flow a little bit more, but there's still no new bonds, no new properties. Chemical properties, on the other hand, are characteristics that change the substance. Chemical properties include things like reactivity, flammability, if something is corrosive, or if something is producing a gas. Here's a good example of a chemical change. So this is called the combustion or burning of methane. Methane is CH4, and when it reacts with oxygen, it produces carbon dioxide and water. So notice how the formulas change. So the name changes, methane and oxygen become carbon dioxide and water. And the properties change. So methane is a flammable gas, while water is a substance that puts out fire. Another example of a chemical change is seen here in the synthesis of water from its elements. So here you can see hydrogen and oxygen, and we'll have to break the bonds that hold these diatomic elements together to create the bonds that are going to form water. So we're making new bonds. So we change from the flammable diatomic elements to the compound water that actually puts out fire. In this picture, notice that two of the oxygen elements are unreacted. That's because matter cannot be created or destroyed, and we don't have the perfect amount of hydrogen. But we did still create new bonds with many of the particles as we created water from its elements. Now, when we look for signs of a chemical change, we're always going to look to verify that we have a new substance that has new properties than the substances that reacted to create it. So what we're going to look for in a description of a chemical change are words like reacts with, combusts, or corrodes. So by now you should be able to differentiate between a chemical and a physical change. Chemical changes always produce new bonds for the new substances that have new properties, but it can take a long time to test all of the properties of a substance in the lab. So to test things like density, flammability, reactivity, solubility, melting point, and boiling point, all those tests can take a lot of time. So we have 5 indicators of a chemical change. None of these indicators are exact proof that a chemical change has occurred, but they're an indication that a chemical change may have occurred, and maybe you should test for the properties to see if you've indeed created a new substance. These 5 evidences include a color change, an odor change, heat or light being given off, a precipitate being formed, and effervescence.
The first evidence is a change in color. You can see here that the Statue of Liberty, which is made of copper, the same metal as a penny, has changed color as it reacted with the air. Cooking food is also a chemical change that is often accompanied by a color change. You know you've cooked your food too much if it has changed color and turned black because you've burned it. Another indicator of a chemical change is a change in odor. You know food has gone bad. It has changed from nutritive molecules to rotten ones when it has a change in odor. Another indicator of a chemical change is the formation of gas. In chemistry, this is known as effervescence. When yeast undergo the chemical reaction of cellular respiration, they produce carbon dioxide gas bubbles. This allows yeast to make bread rise. It also allows yeast to be used in the fermentation process, where you change sugar into alcohol. The fourth indicator of a chemical change is the formation of a precipitate. A precipitate forms when two liquids are mixed together and a solid forms. It is called a precipitate because, given time, the solid will fall to the bottom of the container, just like rain falls from the sky. The final indicator of a chemical change is the production of heat or light. When chemical reactions give off heat, they are said to be exothermic. And when they absorb heat, they are said to be endothermic. We'll learn more about this in unit number 2. Burning is an example of a chemical reaction that produces both heat and light. Since there's no way to see atoms or the bonds that are being made or broken during a chemical reaction, there is no definitive way to know that you've created a new substance without extensive laboratory evidence proving that the properties such as density, combustibility, and magnetism of the substance have indeed changed. But these are still good indicators that a change most likely occurred. Let's look at this Regent sample question. In this diagram, we're looking for a physical change. Physical change means that the bond between the white and black circle is not broken and no new bond is created. These particles will simply be rearranged. So the image that shows a rearrangement of these particles is choice 1.
So let's check your understanding. Can you describe the 5 evidences of a chemical change? Let's see if we can figure out if these changes are chemical or physical. So the rusting of iron. When iron rusts, the metal iron loses its magnetism and it changes from a black-colored metal to a red-colored substance. Rusting is an example of a chemical change. Dissolving in water. When you dissolve something like salt in water, you still have that substance and you still have the water. No new properties, no new substances. This is a physical change. Burning a log. When you burn a log, you begin with wood and then you end with ash. The name changes, so the formula changes, and so do the properties. This is a chemical change. Crushing a compound. If you crush a compound, you still have that compound. The particles are just smaller. For instance, when you were little, did your mom ever crush your medicine and hide it into applesauce? Mine did. Crushing is an example of a physical change. We have now reached the end of Lesson 11, Chemical and Physical Changes. Again, this is the last lesson in Unit 1. That means your unit test is coming up. Start studying now. Make sure that you are prepared to show how much you've learned this unit. I know you've learned a lot. Also, make sure that for this final lesson in Unit 1, you've taken good notes. Write down any questions you have and bring them to class. They could be about this lesson or any of the lessons we've discussed in the unit. It's time to start reviewing. Complete your homework on Google Classroom, and you can get your review sheet on Google Classroom as well. Put your reference table and calculator back in your backpack and start studying now. I'll see you soon.